Hello students, welcome to KENE'S Educare, a group of KENE solutions. This is part 6 of lesson number 2, is matter around us pure? Right? Now as we are going to start with this part 6, and if you remember, we already started with separating techniques. So there are 6 different techniques that we were discussing on, right? So before studying this separating technique, there were some of the important points that we have discussed with respect to solutions, which are the different types of solutions that we have, what are like the concentration of the solutions, then 3 methods to calculate the concentration of solution as well, which includes my mass by mass, mass by volume, and volume by volume, right? Then after that, in the last class, we started with the separating mixtures technique, where we have discussed about evaporation, then we discussed about sublimation, condensation, and there was one more technique, that is filtration, I guess, that we have discussed so far, right? So now we will be studying the further part for all the separation techniques and all the part which has been left ahead for the lesson. Okay, so before starting with this part, I want each one of you to please revise whatever we have studied it before, or whatever notes you have made in your book. I want you all to please revise it once. I hope everyone is revising whatever we have studied so far. Even I will be showing you all the slides, so be ready for it, everyone. Okay. So now we have started this lesson, is matter around us pure, by starting the discussion with respect to classification of matter, right? And here we have studied that any of the product that we get in the market stating as pure is not actually pure. Now the meaning of that pure with respect to scientists is that all the particles in that product, it consists of only a single type of particle. That is what it states. Okay, and we all get misunderstood that it's pure, it is not impure, it has everything which is pure inside it, right? It's not that thing. It's everything in that product is made up of, or it contains only a single type of particle. Okay, so I just want each one of you to please go through the slide once. After this, we discussed on like what exactly a mixture is. So I just want each one of you to please go through the slide as well. After this, like on discussing about what is mixture, we discussed on the types of mixtures through this activity 2.1, right? So there are two different activities that we have discussed so far. I just want each one of you to please go through this slide. After this activity, we had this activity 2.2 where we have discussed with respect to filtration, right? So I just want each one of you to please go through it once. So this is what filtration technique is, that is like that we have studied over here, and we will be like studying about different types of filtration as well. Okay. After this activity 2.2, we discussed on what exactly solution is, right? So I just want each one of you to go through the slide, because the slide is very important, where you have some of the properties of solutions given. Along with the properties, like we have information on diluted, the types of solutions mostly. That is, we have diluted solution, concentrated solution, saturated solution. Okay. So I just want each one of you to please go through it once. After this, like, I hope everyone is going through it. After this, here we have some of the examples of solutions which have been given. So I just want each one of you to please go through the slide as well. I I hope everyone is going through the examples which have been given. After this, now we have the properties of solutions which have been given over here. So I just want each one of you to please go through this once, because this properties of solutions are very important for you all to know, like what exactly they are. Now see, solution is a homogeneous mixture, and over here the particle of solution are going to be smaller than 1 nanometer. That is, 1 nanometer is equal to 10 raised to minus 9 meter in diameter. Okay, so they cannot be seen by the naked eye. Now because they are very much small in size, we cannot scatter a beam of light passing through a solution. Now if you have any solution with you, you won't be you won't be able to pass a beam of light through it, and that is why the path of light is not visible in a solution. Okay, so the solute particles cannot be separated from the mixture by the process of filtration, and that is why they do not settle down when we leave it undisturbed. Okay, so that is the reason that solution is stable over here. Okay, so here we have even like the examples of it given, so I just want each one of you to please go through it once. After this, we discussed on the concentration of the solution, where we have information on concentration of solution, dilute solution, and what exactly you can say saturated, unsaturated solutions are, right? So I just want each one of you to please go through the slide as well once, and then we'll study more about it. After this, like we had this activity 2.3 to discuss, so I just want each one of you to please go through it once. After this activity, like we studied on the concentration of solution, so I just want each one of you to please go through it once, and here we have the three methods for calculating the concentration of solution as well, right? So this is an example on how to calculate the mass of the solution, that is concentration of the solution. And because here they have asked you to calculate in terms of mass by mass percentage, so we have used the formula as mass of solute upon mass of solution into 100. Okay. Then we discussed on the properties of suspension. So I just want each one of you to please go through it as well once. I hope everyone is going through the properties of solution suspension which has been given. After this we discussed on Tyndall effect, so I just want each one of you to please go through the Tyndall effect which has been given over here. After this we discussed on the properties of colloid. So I just want each one of you to please go through this property once, like all the properties of colloid which have been given. Now they can ask you these questions separately as well, or they can even combine the question and ask you to write the properties of solution, suspension and colloid. So in that case, if they're asking you for 6 marks, for 5 marks you have to write it calculating that way itself. Okay. After this properties of colloid, we have discussed on like few examples of colloids which have been given over here. So I just want each one of you to please go through it once. After this, we discussed on separating the components of mixture. So we have started with like evaporation, centrifugation, and separating funnel, I guess. And today we will be covering the sublimation part, chromatography part, and distillation part. Okay, so I just want you all to be clear with like whatever is given on this slide. We will just revise these three techniques, that is evaporation, centrifugation, and separating funnel, and then we will continue with all the three which are left. Okay. So after that we have like this started this in the last class where we studied like how can we obtain colored component from black or blue ink. Now black and blue ink are very common which we use every day, right? So how can we obtain the colored components which are present in them? So we can do that using the process called as evaporation, where we are going to take a beaker full of water and then taking a china dish on it, placing a china dish on it, we have to put the ink on that, like you can say watch glass on it, you have to pour ink on that, and then through evaporation you will see that the water in the beaker, it will get reduced or it can even become empty, and that is how like you can separate the colored component from blue or black ink. Okay, so whenever we have to separate volatile components, that is like if I have to separate solvent from its non-volatile solute, then I can use this method called as evaporation. Okay. After this we discussed on like how can we separate the cream from milk. So we can do this through the process called as centrifugation, where what happens in centrifugation, you have the centrifuging tube, inside that you will add it and you will keep that inside the centrifugation machine. Now you have to start it and there will be a rotation which is going to happen in the tube, and that rotation is going to be very fast. Okay, because of which you will see that the denser particle will like they will settle at the bottom, and all the lighter particles they will just like stay at the top. So this is how we can separate the fat from the milk as well. So I just want you all to please go through this activity once. After this, we discussed on like how can we separate a mixture of two immiscible liquids. Now here we have the example of kerosene oil and water, right? They both are immiscible liquids, they don't get mixed with each other. So like in that case, what we can do, while we have this immiscible liquids, we can always use a separating funnel. So the technique and the application has been explained on the screen, and even I have explained you in the last session. So I just want each one of you to please go through the slide very properly. I hope everyone is going through it. See, the application of the separating funnel can be asked, you can say, as 2 marks question as well. Okay. After this, we discussed on like how can we separate a mixture of salt and camphor. So I just want each one of you to please go through this, and we can do it through a process called as sublimation. Okay, using the process of sublimation, we can separate the component, like that is we can separate salt and camphor both. Okay. After this, we now we need to discuss, is the dye in black ink a single color or not. Okay, so we are going to do that through an activity. So what you need to do is take a thin strip of filter paper and draw a line on it using a pencil, and that line should be approximately 3 centimeter above the lower edge. Okay. So if you can see the paper which has been shown over there, what you need to do is you have to take a filter paper, draw a line using a pencil, and that should be 3 centimeter above the lower edge. Then after that, put a small drop of ink that is water soluble and form a like you can take a sketch pen or a fountain pen at the center of the line. Like can you see the spot of ink and the line drawn by the pencil? So exactly where you have drawn the line, you have to mark a spot of ink over there, and then lower the filter paper into a jar or a glass, or even if you have test tube, beaker, anything that should contain water, so that the drop of ink on the paper is above the water level. Now can you see the ink is above the water level, and you have just immersed the half of the paper where you have marked the line below that into the water, and then you have to leave it undisturbed for some time. Okay, after you do this, you have to watch carefully as the water rises up on the filter paper, and you will see that there will be different colors which will come up. The picture is not given over here. Like if the black ink is made up of many colors, in that case what will happen? In that case you will get different colors which will be formed on the top of the filter paper from where you have made a line. Okay, so the ink that we use has water as solvent, and the dye is soluble in that solvent, right? So as the water is going to rise on the filter paper, it takes along with it the dye particle. So as the water will go up, the dye which is present in that water will also go along with it. So usually a dye is going to be a mixture of more than 2 or more colors. So the colored component that is more soluble in water rises faster, and in this way the color gets separated. So because the colored component is getting separated from water, or from the, because the ink that we have, the dye that we have is made up of two different components, solute and like solvent, right? So water is the solvent and the dye which is present in it is a solute. So while the water is rising up, the dye which is present has always been taken up with it. So if there will be any color, it will go along with the water, it will rise along with the water, and you will see that color, like spot of color which will be formed. And this process of separating the component of mixture We know this process as chromatography. Okay. So chromatography is the technique that we use for separation of those solutes that dissolve in the same solvent. Why do we use this chromatography? For separation of those solutes that dissolve in the same solvent. Okay. So, with the advancement in technology, newer techniques of chromatography have developed. Now, we not only have this one simple technique of chromatography, there are different techniques of chromatographies that we have now, and you are going to study about them in your higher classes. So, chromatography is also one of the technique that we are using it for separating the color, like to find out whether the black ink, it is made up of one or more color. Okay, so I just want you all to write what is chromatography and all the important points that you find. I hope everyone is writing the definition of chromatography and all. So after the definition of chromatography, you have to even draw the figure 2.8 where the separation of dye in black ink has been shown using the chromatography technique. After this, like, I hope you are done with the chromatography technique. The next thing that we have is how can we separate a mixture of two miscible liquids. Okay, so for that we have activity 2.8 which has been given over here. See, let us try to separate acetone and water from the mixture. What are we going to do? We are going to like separate acetone and water from the mixture and take the mixture in a distillation flask, fit it with a thermometer. Now can you see the distillation flask, the round bottom flask, and in that you have to fit a thermometer. Arrange the apparatus as shown in the figure, and then once everything has been arranged, heat the mixture slowly, keeping a close watch at the thermometer. What will you do? You will start heating the mixture slowly, and you have to like look at the temperature of the thermometer very carefully, okay? And while you observe it, you will see that the acetone will vaporize, condenses in the condenser, and can be collected from the condenser outlet. Okay, because in that round bottom flask we have mixture of acetone and water. So when it passes through the condenser, what will happen? The acetone will get vaporized and we can collect them from the condenser through the condenser outlet. So whatever is coming out of the condenser is the acetone, and water is left behind in the distillation flask itself. It's so easy, right? Now acetone and water are two things which get mixed together. So while using this condensation distillation technique, we can separate this mixture of two miscible liquids. Okay, so I just want you all to draw this figure 2.9 and write this activity in your own words. I hope everyone is drawing the figure for distillation. Now you should be knowing the arrangement that we have the distillation flask, we have thermometer arranged on it, and that the distillation flask is being like connected to the condenser, and we have the condenser outlet as well. So you should be knowing the proper labeling and everything. Okay. After this, see. Now this method is called as distillation, where we are separating two miscible liquids, that is acetone and water. Okay, so distillation technique is used for separation of components of mixture containing two miscible liquids that boil without decomposition and have sufficient difference in their boiling point. Okay, why do we use this distillation? For separating the components of mixture where we have two miscible liquids that boil without decomposition, and they are going to have that, like they are going to have differences in their boiling point. Okay, so to separate a mixture of two or more miscible liquids for which the difference in boiling point is less than 25 K. Okay, there will be certain substances which you will find that the boiling point of those substances or mixtures will be less than 25 K, then fractional distillation process is used for that. We cannot use normal distillation process for that. Okay, so if you come to know that the boiling point of the two miscible liquids that you have is less than 25 K, you have to move on to fractional distillation. Okay, and the example given over here is separation of different gases from air, different fractions from petroleum product, etc. Okay, and this fractional distillation apparatus is going to be similar to that for simple distillation, except that a fractionating column is added in between. Now can you see the distillation flask and the condenser? The arrangement is same, it's just that we are adding one more thing in between, that is like called as, what is it called as? Fractionating column. So we are going to fit this fractionating column between the distillation flask and the condenser. Okay, and a simple fractionating column is a tube packed with glass beads. What it is? It is a tube which is packed with a glass bead, and the beads provide surface for vapors to cool and condense repeatedly. Now if you can see the fractionating column, it is going to have small beads in it, and the reason of having those beads are because there will be small gaps in between as well, so they are going to provide surface for vapors to cool, and like they are cooling and condensing repeatedly. So that is the reason we have this fractionating column added in, you can say, fractional distillation. Okay, now because we add fractionating column over here, that is why it has been named as fractional distillation. Okay, so I hope every one of you have understood it. So I want you all to draw this figure of fractional distillation and even write about fractional distillation in short. Now I guess we are just left with one more technique. I won't start it today. I hope everyone is writing the part on fractional distillation, and you are even like drawing the figure for it. Okay. So now I hope you are clear with distillation, fractional distillation, and chromatography technique. Okay. Now next thing that we was how can we obtain different gases from air. So I won't start this today because like you have already studied two, three different techniques today, right? So I don't want your mind to be filled with techniques. Now you actually know five different techniques. Like distillation has two different types of distillation that we have studied, right? So I'll not add on to more. We will start with this in the next class, where we will be discussing about how to obtain different gases from air. Now we know that air is a mixture of gas, right? But like you might not be knowing that you can separate the gas, right? So we will be studying about more over here, and we are going to take fractional distillation, and through this fractional distillation technique we can be able to separate the gases from air. Okay, then after that we will discuss on how can we obtain pure copper sulfate from an impure sample. So we can do that again through the process of crystallization. So crystallization is another technique that we will discuss in detail. So as you can see, like there are different figures and examples which have been given to make you all understand about crystallization technique. After studying the principle and everything about crystallization, we will even discuss the application of it, like what exactly crystallization is used for, what is the application of crystallization. And after that, after discussing crystallization in detail, we will discuss about physical and chemical changes. Okay, so we will be discussing about physical and chemical changes in detail. Then we will discuss on like what are the types of pure substances. Okay, because we can classify pure substances as elements and compounds. So we will be studying about elements in detail, all the like what are elements, everything about elements. Then we will discuss on the properties of metals, like what are the different properties of metal. Then we'll discuss about compounds, what are actually compounds, then activity on it. Okay, and then once we complete our discussion on mixtures and compounds, we will discuss on the differentiation between mixtures and compound. Okay, because this is also very important for you all to know what exactly are the differences that exist between a mixture and compound, because many students get confused with it, like mixture and compounds are one and the same. No, they are not. So we will study the differentiation between them. We will discuss about like how matters are further classified as pure substances and mixtures, where pure substances are further classified as elements and compounds, and mixtures are further classified as homogeneous mixture and heterogeneous mixture. So this table is also very important, which we will discuss in the last class, and this is how we will end up with the lesson: is matter around us pure, by having a summary discussion on it. Okay, but After discussing the summary in detail, we even have few of the exercise questions to discuss. So now I'm going to show you the slides one by one, like all the exercise questions that we have. I want each one of you to please go through the all the questions which have been given properly, and then we will proceed. I'll end this session for today. I hope everyone is going through the questions which have been shown on screen. So this is how we are going to end up with the lesson, is matter around us pure? And I hope whatever we have discussed in this part for the lesson, you're very much clear with it. Now I guess we will require 2 more parts for this lesson so that we will end up with it. Okay, and make sure you are revising each and every part that we are discussing, because as we are moving to the next part, we are at the verge of like ending the lesson, right? And I don't want, like, after I complete the lesson you should not take extra time and sit doing the same lesson again. I don't want that to happen. Okay, so I'll continue with the rest of the part which is left in the next session. Thank you everyone.